Hello, I Anand Jain from Hanumangarh, Rajasthan welcomes you to your favorite Shridevi Classes YouTube channel where we inculcate interest and confidence in science and engineering subject. Today in our playlist of basic electrical engineering and class 12th physics, we'll understand a simple but very popular conceptual question often asked in our examination in electric circuit, and we'll find out average and RMS value of a complex current which have a DC component, a fundamental frequency component and some harmonic component. Let's understand the concept. We have given a complex current signal which have a constant DC magnitude of 3 ampere and a fundamental frequency sinusoidal alternating signal of 4 ampere amplitude given as 4 sin omega t, and there is a double frequency component of amplitude 6 ampere. There may be some other harmonics too, and this complex sinusoidal and DC current having multiple frequency, we have to find out average and effective RMS value of this complex current of DC fundamental sinusoidal component and harmonic sinusoidal component. Now in this complex wave we have two sinusoidal alternating current, and for any sinusoidal current whatsoever its frequency, the full cycle average being equal positive half cycle and negative cycle becomes 0. So these two sinusoidal component of fundamental frequency and double harmonic frequency 4 sin omega t and 6 sin 2 omega t would have 0 average value, and average value is produced only by this DC component. So average value of this complex current wave is only DC part in complex current signal, and that is 3 ampere. So its average value contributed by only DC component is 3 ampere. To find out effective or RMS value of this complex current signal, let's use superposition theorem and let's find out heat produced by 3 component of this complex current signal. One is DC of 3 ampere, second one is fundamental frequency component of 4 ampere amplitude, and the third one is double harmonic component of 6 ampere amplitude. So heat produced by DC component as per Joule's law is I square RT. So when this current is passed through a resistance of R ohm for T time, the total heat produced by only DC component of this current is 3 square RT. Similarly, when only fundamental frequency component 4 sin omega t is passed through the same R resistance for T time, the heat produced by sinusoidal alternating current is corresponding to its RMS value, and RMS value of this 4 sin omega t current component is amplitude divided by root 2, and heating produced in R resistance for T time is RMS value square RT, I square RT. Similarly, this double frequency sinusoidal current component having amplitude 6 ampere got RMS value amplitude divided by root 2, and heating produced by this double frequency AC component in R resistance for T time is RMS value square RT. Now heat produced by individual DC fundamental frequency and double frequency component can be added to find out resultant heat produced by all 3 component together. So total heat produced by all 3 component, the DC component heating is 3 square RT, fundamental frequency component heating is 4 divided by root 2 square RT, and double frequency component got heating RMS value square RT, and the total heat produced can be obtained by adding 3 individual heating of DC fundamental frequency and double frequency sinusoidal current, and when we simplify it, it is 3 square 9. This is 2 root 2. When square is performed, it become 8, and similarly 3 root 2 when square is performed become 18, and the sum become 35 RT. And if this complex current got an effective or RMS value I RMS, then that RMS current will produce I square RT heating in R resistance for T time. And if we equate heating of summation of 3 individual component and heating of equivalent RMS value, then we can say RMS value of this complex current is square of individual RMS currents summation, and it comes as root 35 ampere in this case. This small learning video has solved one of your popular examination question. Our other learning video are equally useful in exam preparation, and if you need exam centric notes and online doubt clearing classes, do join our YouTube membership. Happy learning. Thank you very much.